Have you ever wondered what it would be like to have a mind that could see the universe in numbers, a mind that just instinctively spoke the language of infinity? Well, today, we're going to talk about the incredible life of Srinivasa Ramanujan. Now, to really understand the scale of Ramanujan's genius, we're not going to start at his birth. Nope. Our story actually begins with a secret, a mystery that was discovered in a dusty library more than 50 years after he was gone. So, picture this. It's 1976. At the Trinity College Library in Cambridge, a mathematician named George Andrews comes across this old, dusty box. And inside, he finds a notebook, about 100 pages, just crammed with these dense, handwritten equations. It didn't look like much, but what was inside? Well, that was something else entirely.
That notebook contained over 600 complex formulas, and here's the crazy part, there were no proofs, just these profound, mind-bending conclusions. Andrews was absolutely floored. Some of the formulas describe these weird, almost ghost-like mathematical objects that Ramanujan called Mach theta functions, ideas so far ahead of their time they are now critical to understanding the physics of black holes. It was like a final, cryptic message from the past, and it left everyone with one burning question. Who on earth was the mind behind this?
To answer that, we've got to go back in time, all the way back to a small town in late 19th century India. That's where the story of this unbelievable child prodigy begins.
Ramanujan's genius just ignited. By the time he was 11, he had already surpassed the knowledge of the local college students. At 13, he wasn't just learning math, he was discovering his own original theorems. But the real spark came when he was 16. He got his hands on a book that had 5,000 theorems in it, but zero proofs. For anyone else, it would be a dry reference manual. For Ramanujan, it was a playground. He set out to prove every single one, and in doing that, he unlocked this absolute torrent of his own original work.
You see, he wasn't just some smart kid. He was operating on a completely different plane of existence. His peers said it themselves. They rarely understood him and just stood in respectful awe. He was living in this world of numbers and patterns that, to pretty much everyone else, was completely invisible. But here's the twist. This incredible, singular focus on math, it actually became a problem. He was so consumed by it that he started neglecting everything else. He failed his exams, he lost his scholarship, and all of a sudden, the very gift that made him so extraordinary was the biggest obstacle to his education.
And this is where his life enters this period of intense struggle. You have this stark, almost unbelievable contrast between the infinite world that was exploding inside his mind and the harsh, finite reality he had to live with every single day.
I mean, just look at this. This was the central conflict of his life. His mind was rediscovering 100 years of Western mathematics all by itself. But in the real world, he couldn't even afford paper. He was scribbling these profound ideas on a small slate and then wiping them away to make room for the next one. He was living in extreme poverty, but his mind was traveling to the farthest reaches of the mathematical universe.
So there he was, working as a simple clerk in Madras. But Ramanujan knew that his discoveries were too important to just keep to himself. He had to reach somebody who could actually understand what he was doing. And he set his sights on the epicenter of the math world at the time, Cambridge University.
His first few attempts were, well, they were a bust. 2 professors at Cambridge just sent his papers back, no comment. But Ramanujan kept trying. In January of 1913, he sent out a 3rd letter. This time it was addressed to G.H. Hardy, one of the most brilliant and respected mathematicians of the era.
You know, Hardy's first reaction was to just dismiss the letter as the work of a crackpot. But the formulas, they were strange. They were haunting. He couldn't get them out of his head. That evening, he and his colleague J.E. Littlewood looked at them again, and they realized these formulas were unlike anything they had ever seen. They were so wild, so imaginative, that, as Hardy famously said, they had to be true because no one could possibly have the imagination to invent them. Right there, in that moment, they knew. They had just discovered a genius of the highest possible order.
That one single letter changed absolutely everything. It set in motion what would become the most productive, the most celebrated, and ultimately the most tragic chapter of Ramanujan's life, his time in England.
So Hardy brings Ramanujan to Cambridge, which, as you can imagine, was a massive culture shock for the young man. Their collaboration was just electric. It was a collision of 2 completely different worlds. You had Ramanujan, the pure, intuitive genius who said his ideas came to him from a goddess, and then you had Hardy, the ultimate logician who demanded rigorous, formal proof for every single step. But this unlikely duo produced extraordinary results, and it earned Ramanujan these unbelievable honors, like becoming a Fellow of the Royal Society and Trinity College.
But the cold English climate and the food rationing during the war, it took a serious toll on his health. One day, Hardy went to visit him in the hospital. And, just trying to make small talk. Hardy mentioned that the number of the taxi he took was 1729, and he remarked what a dull, uninteresting number it seemed to be.
Ramanujan, lying there sick, didn't miss a beat. He immediately replied, "No, it is a very interesting number."
From his sickbed, Ramanujan just casually explained that it was in fact the smallest number that could be expressed as the sum of two cubes in two different ways. What was just a random string of digits to a brilliant mathematician like Hardy was like an old friend to Ramanujan. That number, 1729, is now famous all over the world as the Hardy-Ramanujan number. But here's the really tragic part. His health completely collapsed. The doctors in England diagnosed him with tuberculosis. But modern analysis looking back suggests it was probably hepatic amoebiasis, a parasitic liver infection he likely got back in India, and one that could have been treated. That misdiagnosis was just a devastating turn of fate. He returned to India in 1919, gravely ill.
Ramanujan passed away in 1920. He was only 32 years old. His life was tragically short, but his mathematical legacy, well, that's infinite. In the centuries since he's been gone, we've only just begun to understand the true depth of his work.
So how do you even measure a genius like this? It's almost impossible. But G.H. Hardy, the man who knew his work best, he actually tried. He created a scale for pure mathematical talent. On a scale of 100, he rated himself a 25, he gave his brilliant collaborator Littlewood a 30, and the great David Hilbert an 80. And Ramanujan, he gave him a perfect 100.
And why a perfect score? Well, because his work isn't some historical relic locked away in a book. It is alive and working today. Formulas from his notebooks are used in modern algorithms to calculate pi, they're used in computer science and in string theory. And like we talked about, those mock data functions are helping us unlock the secrets of black holes. He wasn't just a man of his time. He was decades, maybe even a century ahead of it.
So when you boil it all down, his story is just one of these breathtaking contrasts. A self-taught genius who came from nothing and completely revolutionized mathematics. He was the bridge between pure intuition and formal proof. He left behind this treasure trove of ideas that mathematicians are still trying to figure out, ideas that are now powering fields he could never, ever have imagined.
Ramanujan was a once-in-a-century kind of mind, one that was almost lost to the world entirely and was only saved by a single letter. As we continue to unravel the secrets in his notebooks 100 years later, it really leaves us with one profound question. How many more hidden geniuses are out there right now, just waiting for one person to see them?